webcast is now starting. All attendees are in listen-only mode.
Yes, hi, good morning, everyone. Good afternoon. We're going to start our webinar in 60 seconds. People are still signing up. We are waiting for them, but we'll start in 60 seconds. So today we are going to talk about ANSYS structures. What's new in 2020 R2? Please give us 60 more seconds. Thanks. Okay, so we'll get going here. Again, good morning, good afternoon. So today we are going to talk about ANSYS structures, what's new in the new version of ANSYS 2020 R2. As you know, ANSYS releases 2 versions a year. The first one is 2020 R1. The first release usually comes out at the end of January or early February. And the next one comes out in mid-July timeframe. And this release, it was just made public last week, July 15. So today's presenter is Dr. Ahmet Algandur. He is one of our senior engineers. And next slide, please. And a little bit of who we are, what we do. Ozen Engineering. We are an ANSYS Elite channel partner. And we have engineers that support our customers that use ANSYS. And we have a multidisciplinary team. We have mechanical engineers, civil engineers, electrical engineers on our team. And all we do is FEA, CFD, high and low frequency electromagnetics. Next slide, please. And we support the full ANSYS portfolio. As you know, the full ANSYS portfolio includes structures, and that's the topic of today. But we also have fluids. We talked about fluids yesterday. We have a brand new physics called optics, Optis. That's the name of the product. It's really optics physics. Anything related to light modeling can be done using our solver called Optis. And we also do a lot of electronics. That's what we call EBU, Electronics Business Unit. And we also get into digital twins. If you're interested in these topics, you can visit our website, www.ozeninc.com. We have sections on digital twins. We have sections on fluid structures and also 3D design. Next week, we are going to have or in the next couple of weeks, we are going to have a session on discovery products. That's all the way on the left-hand side here. The new discovery product is very interesting. That's something for everyone to see. Anyway, next slide, please. We have our webinars. We have a bunch of webinars, as you see on the right-hand side. Anything from antenna simulation to fracture mechanics to ANSYS Cloud. These are on our website. If you go to ozeninc.com, under resources, there's a webinar library. And you can see that list. And also towards the bottom, you will see that we have divided up into structures, fluids, and electromagnetics in case you'd like to take a look at them under different topics. Next slide, please. And we will also put this presentation on our YouTube channel. So in case you missed parts of it, please feel free to watch it on our Ozen Engineering YouTube channel. So we are here to support you, our customers. We are here to serve you with ANSYS support. If you have any questions, you can send them to info@ozeninc.com. If you have technical questions, you can send them to support@ozeninc.com. And you can call us 408-732-4665. So we are here to support you, ANSYS users. And in case you're short in manpower, we also provide consulting services. So feel free to contact us. So next slide, please. So today's presenter is Dr. Ahmet Alkandur. He has a BS in mechanical engineering from Cairo University in Egypt. He has a master's in mechanical engineering from University of Illinois at Chicago. And he also has a PhD in civil engineering from University of Illinois at Chicago. He has 10 plus years of experience in finite element analysis, 8 plus years in using ANSYS, and his expertise are anywhere from structural, linear, nonlinear analyses, static dynamic, and also thermal stress analysis. So with that, I'll turn it over to Ahmet.
Thank you, Dr. Ozen. I appreciate the introduction. Hello, everybody. As Dr. Ozen said, I will give you an introduction, a quick presentation about what is new in ANSYS 2020 R2 in the structure products. I will try to cover these topics. There is a lot of updates and new features that ANSYS added to 2020 R2 in the structure field. I'm not presenting all of them because there are too many, but feel free to contact us anytime on info@ozenengineering if you have any question on one of this particular topic, and we can share what is new in this particular topic in case I didn't add everything. I'm going to cover what's new in ANSYS Mechanical and Workbench, Linear Dynamics, Workbench Additive, ANSYS Composite, PrePost, LSDYNA, Rigid Body Dynamics, Sherlock, ANSYS Motion, Materials, and Discovery Live. So I'm going to start with ANSYS Mechanical. One of the newer feature is now you can control your license, what you want to use, what's going to be your main license. Basically, you can use the up and down buttons here, so you can move whatever your preferred license, and then you can enable or disable the rest based on your preference. And once you start, restart Mechanical, whatever setup you made, that will be your default unless you change it later. Another new feature is related to contact. We know that ANSYS have what's called contact tracker, which you can use to track the contacts number, how many nodes in contacts during the solution in progress. But now ANSYS added new trackers that you can use, such as what is the pair force convergence norm, also what is the force criteria. You can track the penetration pressure on both contact and target surfaces for any particular contact of interest in your running simulation. Another feature that ANSYS added is you are allowed now to delete any external data that you imported in your model. Before that was not possible, but now you can delete that, and if it's read-only, you can change that, and then you can delete whatever you want. Another new feature is ANSYS now allows the user to add command objects to point mass, thermal point mass, and distributed mass objects. In case you are not familiar with command object, basically command object is a script you can add to any of your at different location to modify your simulation or geometry or something using APDL commands. Before that was not allowed for point mass, and but now it's allowed, and people can use it to modify its properties using commands object. a new feature which is really interesting is you can, if you're trying to import some thermal results like temperature, for example, and instead of coupling your system to another system, you can just refer to the results file. So you don't need to link. You can only use the import load result file here and then import the result file, and it will be imported directly to your system. And we can see here the location of the file instead of having a coupling between the two systems on the Workbench. And by the way, at any time, if you have any question, just add it to the question section in the webinar tools, and I will try to answer them on the fly, or if not, then at the end of the webinar. Okay. Another feature added in 2020 R2 is selection. We know before you can select faces, and then you select the extension of this faces that in contacts. But now you can even select faces or surfaces that are not in contact, but on the same plane. So we can see here, you can select by location, basically on the coplanar entities with the same X or Y or Z location. As you can see here, in this direction, we can see this selection happening by selecting one, and then you can extend the other selection. Another feature also is reinforcement. Now you can use reinforcement using the mesh independent method inside ANSYS Workbench. Basically, you can define the bars using the bodies. You can select linear bodies, or using line bodies, or using surfaces for smeared reinforcement. Before, all of these was doable, but using APDL commands. But now you can do that inside mechanical. You can see here you have line bodies. You can define, instead of beam, you assign it as reinforcement, and for the same for the surface body, you define it as reinforcement, and you can then specify the material assignment, as well as the cross-section area, and also the gap between them. Another feature added is, it's not a new feature, but it's improvement of the shell to solid contact. That's an enhancement happened in 2020 R2, basically using the SHSD APDL command to be the default for any contact between shell and solid bodies or elements, sorry. But this feature is only supported if you're using bonded contact with MPC formulation, and the constraint type is specified to projected or displacement only, or projected U to ROT. And here is an example of that. You can see on the left, this is an older version where SHSD command was not used as default. Now it's used as a default inside the contact, and we can see how the connection here is way smoother compared to the previous versions. Another feature is ability to restart from specific steps. Before, people cannot specify which steps to restart the solution from. It's usually wherever it stopped. But now you can specify a specific load step that you can use to restart your simulation that you paused at any time, and then you can restart from the step that of interest for you. People using cyclic symmetries, you know that before they cannot use imported loads, but now in 2020 R2, using a tabular loading option, you can import the body temperature to your cyclic region, like this part here, and then you can solve your problem with the imported load to part of your cyclic symmetry. Another feature in contact, which is a very useful contact tool, is basically now ANSYS combines the three contact detection method together in one approach. Basically, the contact detection at the Gauss point and at the nodal point and the surface projection. This will make the solution is easier and more robust. And we can use this by defining the contact definition as symmetric. It's now better, especially in cases when we have interface fit or press fit or snap fit. It will work smoother now, and it will be easier to converge compared to previous contact techniques used are separately. But now it's now combined together and give us much better performance. Another improvement is related to the preload technique for the pretension. A lot of engineers need to use a pretension load inside their analyses, which is straightforward to use, and a lot of people are happy with it. But in some application, if you are having some rotation, like in this case, it will cause troubles. But now with some improvement that ANSYS applied and by using different contact approach, we can see that even with the rotation, it's still maintained the same values of stresses, which before would be a problem because when rotation, the definition of coordinates will be a problem. But now this has been improved. Another improvement in 2020 R2 is related to the contact robustness, especially for nonlinear solution. We know that robustness is very important, and for that, ANSYS added some improvement, especially with MPC generated and for MPC contacts, which will improve the convergence performance, as well as the theory, the logic of the bisection and the contact damping as well. So they added improvements for the bisection and the damping that will make it easier to converge, and also it will make it faster to solve compared to the previous setup. Another feature added is quasi-static solution. It's now extended to all physics types inside ANSYS. We can see here we have a problem that was solved with full transient analysis, and it's solved using the new quasi-static solution. And we can see how it's improved in the number of iteration, and also in the convergence is also much easier using this quasi-static. It's we can see it's using the backward Euler time integration, and it can be good for a lot of type of problems that can benefit from the quasi-static approach. Okay, another significant feature here is the thermomechanical fatigue materials parameter fitting. Now people can use their experimental data to fit the curve and provide it inside ANSYS with a very high accuracy and high level of representation, which can be especially for plasticity model, as this model we can see here, isotropic plasticity, and we have rate dependent plasticity, bilinear isotropic, Chepachy kinematic hardening. A lot of materials now could be easily fitted or have a parameter fitting based on the experimental data. What we can see here is an example for that. You can see here the stress versus time plots and the stress versus strain plot, and we can see a perfect matching between the experimental data and what is inside ANSYS right now. So this is a really important feature, especially people who do a lot of experimental testing to extract some material information, especially if you're using a specific material that is not very common to find in the standard databases. For the fatigue analysis, We know that in fatigue analysis, you need to use a load cycle and you have to repeat that a lot of times. But now we can use what's called accelerated fatigue analysis using cycle jump. Basically, a new cycling loading is used, and that will help to maintain the same performance, but will need much less number of cycles to solve the problem. As you can see here, the new cycle jump analysis allow for acceleration of fatigue analysis by jumping across the cycle based on control function criteria. There is some criteria you need to apply, and then you can use, instead of repetitive cycle like this, you use this accelerated cycle jump. In this slide here, we can see there is before and after. We can see the performance and the results looks exactly the same, but we can see that the total cycle was 57 with the new cycle jump instead of 100, which will save a lot of time without affecting the performance. Another enhancement, this is mainly for customers that are using a large model with a lot of cores and a lot of millions of degrees of freedom. ANSYS now have improved the performance and the solution speed up compared to 2020 R1. We can see here, especially as large scale, there is a lot of enhancement happening here. And this example here for on the left, that's a 50 million degree of freedom turbine that is solved, and we can see ANSYS can handle it with no problem using the hardware that can handle that, and we can see there is some improvement happening in the solution speed up. For the optimization, people who do optimization inside ANSYS, there is a lot of now, this mainly for topology optimization. If you're using topology optimization, we can see there is a lot of constraints can be applied, and we can use volume, mass, center of gravity, moment of inertia. And for the optimization region, now you can apply a lot of region instead of one or two. Now you can apply a lot of optimization region, with each one have its own set of manufacturing constraint. You can also do static linear analysis using UDF work with displacement and reaction force, but this is still beta function. This is a new beta function that's applied. So this is the one that's already there with the new version, fully tested and working with high efficiency. And we can see here, for example, we have this geometry here. We have like 3 regions, and each region has its own constraint. And we can see that based on different constraints, we can see the finalized optimized shape can change based on what is the main constraint and what is your optimization region of interest. And we can see that we can achieve different final geometry based on what we're really looking for, which is really, really interesting, because it's a nice improvement. Instead of having just one region for everything, now we can even divide our geometry, or if we have an assembly, we can work on each one individually in the same solution. All right, so that was mainly the most significant improvement in Workbench. As I said, I'm not showing everything because there is tons of it, so and we are limited on time. So I will now move to linear dynamics. When we say linear dynamic, we're talking about harmonic analysis, transient analysis, modal analysis. So in this linear dynamic, some improvement is related to reading the element result directly from files. And now also we can support frequency response charts in harmonic. We can support velocity and acceleration in transient. And we can support now reaction forces based on props in harmonic, transient, frequency response chart in harmonic as well. Another improvement is in modal analysis. We can now add, for a modal analysis, we can import body temperature. That was not allowed before. So we can use external file, import some temperature, and add it to a model analysis. Importing temperature, it could be for transient analysis, we can import temperature, which we have done before, but now we can define it as either initial condition or boundary condition, and we can apply it for any thermal, transient thermal, thermal electric, and steady state thermal analysis as well. Okay, now we're going to talk about the additive manufacturing. In general, ANSYS have different platform for additive manufacturing. We have the additive prep, which is basically related to it's connected with Space Claim that will help you to generate your geometry, prepare your geometry for the body and support and everything you might need, even scripting. And it has its own improvement as well. There is ANSYS Additive Workbench, which I'm going to talk about in detail. There is Additive Print, which is another software that ANSYS have for additive print, different than Workbench Additive. And then we have Additive Science. Additive Science basically focus on the microstructure and the micro scale of the material instead of the printing itself, but now it focuses on the material. I will, for sake of time, I will only focus on Workbench Additive because that's the majority of our customers are focusing on Workbench Additive. So one of the improvements happening in ANSYS Workbench that now the voxelization Cartesian mesh, which is before was used in additive print, is now added or included in Workbench. We can use that now. We can generate continuous Cartesian mesh between build parts as well as its supports. Okay, and this is very useful for the workflow. It makes things easier and faster to solve. Another thing added in additive Workbench is the use of the cutoff. We can now use it by direction. That was used before using an APDL in additive print, but now we can use it here as well by defining which direction we are interested in for the cutoff. One significant improvement in Workbench Additive is the wizard. The ANSYS wizard is basically a step-by-step tool that help you to take your simulation from the beginning to the end, especially for new users, and that have been improved to include the STL support, the voxel meshing, and the expand use of layer tet meshing as well inside the new wizard. For the ANSYS Composite PrePost, there have been also different modification. Now, mainly related to 3D ply surface mesh independent layout mapping. Now, you can import the geometry of the 3D ply, the new feature, which allow you to layups independently of the shear reference surfaces. Okay, like we can check here the case. You can import off layup definition directly from any CAD system and map them into the independent solid mesh. For another improvement on the layup mapping is also adding the layup. Adding the layup mapping. That's a new feature, and there is another enhancement was done on the robustness of the layup mapping as well. In the new version, the user can now post-process the imported solid model, which was not available previously, were only possible using the composite failure tool. The HDF5 composite is now support the new 3D ply workflow with imported modeling plies. Also, the new extract material, we can now extract material from one form to another like from the HDF5 to the XML, which is the engineering data of ANSYS. We can do that right now. I mean, with a newer version. Another improvement was related to the material, because now there is some new materials have been added to the library of the PrePost as well. Okay, for users of LSDYNA and explicit dynamics, there is now you can use what's called smooth particle hydrodynamics, which is basically using particles to represent objects. It helps in visualization, it helps in meshing, but you need to specify specific settings before the analysis. For Workbench, LSDYNA is now defined as LSDYNA. Before, if you look in the system, before there was what's called Workbench LSDYNA and Workbench Workbench Restart, or Restart Workbench LSDYNA. Now it became directly LSDYNA and LSDYNA Restart inside the systems of Workbench directly. For LSDYNA users, we show here some examples of how we can couple different fields like electromagnetics with incompressible fluid dynamics, as well as mechanics for this hard analysis. Also, we can use implicit incompressible SPH, and we can see here an example of a car moving through the fluid. It's tailored for welding type problems. Another improvement is related to the porous media. We can now model 2D to 3D FSI porous permeable, like for the example here, the parachute and the face mask. So there is a large number of porous media models. So it's important that we keep it simple, but still sophisticated enough so we can keep adding different model without reshaping the interface too much. So this is what helps in this new interface. Here is an example of the ICFD sliding mesh inside LSDYNA. We can see some example for the wind turbine, as well as the blood pump here, which is showing the capability of LSDYNA when it comes to rotating machinery and how the flow property of transient or steady state can be defined, which will help to avoid a mesh distortion. This is mainly for users of LSDYNA customers. Okay, inside LSDYNA, another feature is added is using the card of database D3FTG. We can do fatigue damage growth simulation. I think we have some videos here as well to show, which will help to improve the fatigue performance using this card. Another useful card is the fatigue failure. This will help also to capture the fatigue failure, as we can see here, using the fatigue failure card inside LSDYNA. Also, one thing to add for LSDYNA user, now you can use element birth and death, which is a very useful tool in general in any FEA tool, because it can save a lot of time. Okay, for rigid body dynamics, the settings have been simplified and more automated to help the user to use what is the best for them without a lot of, and make things more program control and automated based on the best practice of this type of analysis. The time integration choices have been reduced as well to facilitate for the customer to only these options we can see here for the under this menu here. Another feature for the rigid body dynamics inside 2020 R2 is friction in joints. Now friction was already available in transaxial cylindrical, but now we can have it in universal, spherical, slot, point on curve joint, and imperfect joint. So all of these joints before we didn't have friction in, but now friction is available inside this joint inside rigid body dynamics. Okay, now we'll jump to Sherlock, and again, please, if you have any question, type it in the question section before you forget, and I will try to answer it at the end of the webinar. Okay, Sherlock, a quick look in Sherlock here in case some of the engineers don't know what Sherlock is. Sherlock is a thermal analysis for and mechanical analysis for electronics and PCB boards with its component in sophisticated area. The good thing about Sherlock, you can couple it with SI wave, ISPAC, mechanical as well to do some two-ways analysis between Joule heating and temperature, or mechanical analysis for stress analysis. Sherlock is also a strong tool for reliability analysis when it comes to electronics and PCBs and its component. So one of the improvement now is Sherlock can export of reinforcement. Reinforcement now can be captured, like added, and which are very important for this type of analysis because it can affect the reliability analysis. So now we can have better representation of the board and its component using the reinforcement, which will help to have an exact solution, and you have better implementation of the board and its component, and you can do whatever analysis you want for Joule heating or fracture and thermomechanical fatigue. All of this will be which already be captured now will be captured with more accuracy. You can see here the PCB is meshed with the reinforcement, which will make it more accurate and will give us even better representation. It works in 1, 2, and 3D geometry based on space claim. And of course, we are adding the traces and the vias and all the small details that included in the PCB analysis. Here is the workflow that how this is done. Basically, we do the analysis in Sherlock by exporting the traces and vias and the PCB and its components. We bring it here for the analysis, and then we go space claim if needed to do some modeling, and then we go to ANSYS mechanical to do the reinforcement and setup, and then we can do ANSYS mechanical post-process result on the traces. Here is another way to represent the workflow: Sherlock, and then harmonic analysis, and then we can bring it back to Sherlock as well. It's a very strong and very useful tool, that this coupling happening inside Workbench between Sherlock and mechanical, because it can give us a wide understanding and very in detail and in-depth understanding of the different component of the PCB in one platform. So it saves a lot of time, it saves a lot of money, and the engineers who are familiar with mechanical can capture it in no time. All right, so now we move to ANSYS Motion. ANSYS Motion is basically one of the ANSYS software that have been acquired, I think, last year, which basically do some multi-body dynamics analysis. So it have a lot of toolkits to do some multi-body dynamics for different components like joints, like bearings, springs, rigid and flexible components. In 2020 R2, one of the new toolkits added is that Drivetrain, as well some links that will help, both of them will help to model different components in like vehicles, trains, and gearboxes, and all this complicated multi-body dynamics systems now we have even more tools to help to create that. For example, Drivetrain, you can use it to build a model for gear train system with Drivetrain Toolkit. For the links, you can use it to build chain, trace vehicle system, etc. Like this one we see here, this is a gear set here, and we can use a drivetrain to create this by defining gear, by defining bearing. We can have different type of bearing, like sliding bearing here. We can have regular ball bearing, and for the gears there is internal and external gear set. All of that inside this toolkit to help you to model your system more accurately. Like this model here, for example, we can see we have a different component. Another improvement is the links, which we can see we can define a path or a segment or link simpler or link connector. Like here, we have this chain connection here. Let's see an example of that. You can see all of that is modeled with high accuracy using the new toolkit inside ANSYS Motion. So there is also different standalone inside Motion that help you to do a specific tasks. Like all these tools here, we can see we can use this package, the link or the drivetrain or the basic one, excuse me, to do a lot of specific analysis based on the needs of the engineers who's doing it. Okay, one of the tools here, for example, is a continuously variable transmission modeling tool, or CVT. We can see it have its own graphical user interface to define all the needed details for all the component included with highly detailed representation and highly accurate solution. Also, the cross helical gear is one of the tool set that can be used inside ANSYS Motion, which will help you to create the gear with all the needed information to create one with high details, and that's one of the really strong tools of ANSYS Motion, that you can have a specific gear built inside it, and you do the analysis needed for the multi-body dynamics analysis. Same thing with one improvement is the solving time. When we have multiple contexts, the solving time now have been the algorithm have been improved to optimize solution, so we can reduce the time from for example, this one here, it used to be 19 hours, now it's only 3.5 hours after improving the contact algorithm. Another improvement in ANSYS Motion is the contour plot for the contact results. Now we are able to apply we are able to obtain contour plots for different contact results, like friction, like stick up, slipping condition. All of that was not available before. Now it's improved and added to the ANSYS Motion capabilities. Okay, so now we will move to the what is new in 2020 R2 in materials. We know that ANSYS, when it comes to ANSYS material, we know we have the material data simulation, which is the database that can be used inside structure, fluid, electromagnetic, and discovery. We know there is a Granta selector, which is a software that you can use to access a lot of materials and help you to select what material you need for your design, what is similar materials, what is a comparison between different materials. It's a really, really useful tool, Granta selector, especially at the design and selection of materials for a new design, and also for the situation when you need to change the material at any time. You can go and compare. You can compare by property, by price, by availability. All of this you can do in Granta selector. And then we have Granta MI Pro and Granta MI Enterprise, which is a huge database that can be used for enterprises and big companies that can combine, first store their data of their own material, compare their material with what is material available in the market, and then they can unify the material between their different departments, so there is no duplicates of information, there is no change of properties from the purchase department to the design department to the manufacturing department to the analysis department. Once you have this database, you can be every single department using exactly the same material for everything. So here we can see that in 2020 R2, now MDS is basically material data simulation, is now available inside mechanical, electronic desktop, FLUENT, and Discovery. And there is a lot of material, over 700, with all its needed information. It's now available for structure. In electronic and FLUENT, there is also extensive database based on the material property needed for each type of analysis. We know for each analysis you will be looking for a specific set of material properties, so that change from an application to another. But the good thing is the MDS is available in all of them. This is Granta Selector. What is new in it? It's now can be imported to ANSYS and go. It can export it to ANSYS Granta MI Pro. And it's updated its database, so it contains now over 2,600 records of statistically derived design data for aerospace alloy. It's really rich library with a lot of references and material database that a lot of users really like, because it can help them to select what material they need. What's new in Granta MI is now import material data from Granta Selector. It can direct access to material data within Creo, SolidWorks, and also increase the material available on the reference database. Okay, now we'll go to the last part, which is discovery. ANSYS used to have a Discovery Live. Now we have two tools, Discovery Live and ANSYS and Discovery. So I'm starting with Discovery. In Discovery, it's basically consists of three parts: the design exploration, verification, and innovation or analysis. Basically, you can import to your CAD, do your analysis on the fly because you don't control the mesh. That's in the explore part. But you can also go to the analysis and you can do some meshing. One new features is that now it's include the Granta material. Once you do the analysis here, you can export it to ANSYS Mechanical or ANSYS Fluent. It have a very useful interactive help. Basically, when you select the help, it can highlight everything and tell you what that's exactly doing. And you can do some modification, and on the fly you can see how the improvement happening, what's increased, what's decreased. So this is ANSYS Discovery. It's really useful tool and can solve a lot of what-if question for engineers. Here's what I was talking about, the model, basically the CAD, Explore. This is like the typical ANSYS Discovery Life. And then here is the Analyze tab, which basically it can allow you to do some to have more control on the physics and also on the mesh, and to have a higher level of confidence by making it more accurate by controlling the mesh and the contact tools. For the typical Discovery Life, they made some improvements, so the performance is now better. You can see this is better, faster solution, as well as better representation of the real situation. You can see that also here on the improved result rendering. You can see now the results looks way better, and also it have now a topology optimization, which is based on 1D pole constraint, 2D CNC, frozen region, as well as support for displacement and acceleration fluid. And you can see here this is done inside ANSYS Discovery Life. There is now some optimization you can do if you have a design and you want to see how it should look using the optimization. And with that said, I am done. I'm sorry if I exceeded the time, but I'm so excited because 2020 R2 have tons and tons of new improvement. I just show the most important ones, but if you are interested or if you have any question, please ask me now in the question part, or feel free to email my email or even info@ozeninc.com with any questions you might be interested in. Thank you, and let's see if you have any questions.
Yes, thank you, Ahmed. So that's a lot of material to cover and a lot to absorb as well. If you have you like anything that you have seen in this presentation, because Ahmed went through a lot of different materials, anything from the new discovery to LSDYNA and to reliability simulations. If there's anything you'd like to see, please send us an email, either info@ozeninc.com or Ahmed's email, elgander@ozeninc.com, and let us know what you would like to see, and we will send you, we will set up a time just to cover the topic of interest in more detail. So, this is really a lot of material. So, please let us know if you have any questions and or you would like to see a specialized demo on any one of these new features, new products. So, with that, I think we are done for the day. I don't see any questions, but thank you for attending our webinar and look forward to working with you and supporting you with these ANSYS products.
Thank you, everyone. It was a pleasure giving this webinar to you. Have a great day. Thank you, Metin. Thank you. I appreciate it.
Thanks, Ahmed.
Goodbye, everybody. Bye-bye.